Ladies and gentlemen, hello and welcome back once again to episode 2 of TechWise. Yes, indeed, it's time to get wise, people. We've got a bunch of really smart people on the line today to help us in that endeavor. My name is Eric Kavanagh, of course. I will be your host, your moderator for this lightning round session. We have a lot of content here, folks. We have some big names in the business, 2 of the best analysts in our space, and 4 of the most interesting vendors. So we're going to have a lot of good action on the call today. And, of course, you out there in the audience play a significant role in asking questions. So once again, the topic is TechWise, or I should say the show name is TechWise, and the topic today is how can analytics improve business? Obviously, it's a hot topic. We're trying to understand the different kinds of analytics you can do and how that can improve your operation, because that's what it's all about at the end of the day. So you can see myself up there at the top. That's yours truly. Dr. Kirk Borne, our good friend from George Mason University. He is a data scientist with a tremendous amount of experience, very deep expertise in this space, in data mining and big data and all that kind of fun stuff. And we, of course, have our very own Dr. Robin Bloor, chief analyst here at the Bloor Group, who trained as an actuary many, many years ago and has been really focused on this whole big data space and the analytics space quite intently for the last half-decade. It's been 5 years almost since we launched the Bloor Group per se, so time flies when you're having fun. We're also going to hear from Will Gorman, Chief Architect of Pentaho, Steve Wilkes, CTO of WebAction, Frank Sanders, Technical Director at MarkLogic, and Hannah Smalltree, Director at Treasure Data. So like I said, folks, a lot of content. So how can analytics help your business? Well, how can't it help your business, quite frankly? There are all kinds of ways that analytics can be used to do things that improve your organization. So streamline operations, that's one that you don't hear as much about as you do about things like marketing or raising revenue or even identifying opportunities. But streamlining your operations is a really, really powerful thing that you can do for your organization, because you can identify places where you can either outsource something or you can add data to a particular process, for example, and that can streamline it by not requiring someone to pick up the phone to call or someone to email. There are so many different ways that you can streamline your operations, and all of that really helps bring down your costs, right? That's the key, brings down the costs, but it also allows you to better serve your customers. And if you think about how impatient people have become, and I see this every single day in terms of how people interact online, even with our shows, service providers that we use, the patience that people have, the attention span gets shorter and shorter by the day. And what that means is you need to, as an organization, respond in faster and faster periods of time to be able to satisfy your customers. So, for example, if someone is on your webcast site, they're browsing around trying to find something, if they get frustrated and they leave, well, you might have just lost a customer, and depending upon how much you charge for your product or service, maybe that's a big deal. So the bottom line is that streamlining operations, I think, is one of the hottest spaces for applying analytics. And you do that by looking at the numbers, by crunching the data, by figuring out, for example, hey, why are we losing so many people on this page on our website? Why are we getting so many phone calls right now? And the more real time you can respond to that kind of stuff, the better chance you're going to have of getting on top of the situation and doing something about it before it's too late. Because there is that window of time when someone gets upset about something, they're dissatisfied, or they're trying to find something but they're frustrated. You've got a window of opportunity there to reach out to them, to grab them, to interact with that customer. And if you do so in the proper way with the right data or nice customer picture, understanding who is this customer, what is their profitability, what are their preferences, if you can really get a handle on that, you're going to do a great job of holding on to your customers and getting new customers, and that's what it's all about. So with that, I'm going to hand it over actually to Kirk Borne, one of our data scientists on the call today, and they're pretty rare these days, folks. We've got 2 of them at least on the call, so that's a big deal. And with that, Kirk, I'm going to hand it over to you to talk about analytics and how it helps business. Go for it.
Well, thank you very much, Eric. Can you hear me?
Just fine. Go ahead.
Okay, good. I just want to be sure before I talk for 5 minutes and people are waving their hands at me. So the opening remarks, Eric, that you made really tie into this topic I want to talk briefly about in the next few minutes, which is this use of big data and analytics for data to decisions to support there. And the comment you made about operational streamlining, to me, sort of folds into this concept of operational analytics which you can see just about in every application of the world, whether it's a science application, a business, a cybersecurity, a law enforcement, a government, healthcare, any number of places where we have a stream of data and we are making some kind of response or decision in reaction to events and alerts and behaviors that we see in that data stream. And so one of the things that I'd like to talk about, I'll talk about today, is sort of how we're extracting the knowledge and insights from big data in order to get to that point where we can actually make decisions, take actions. And frequently we talk about this in an automation context. And today I want to blend the automation with the human analyst in the loop. So by this I mean the business analyst plays a very important role here in terms of vetting, qualifying, validating specific actions or machine learning rules that we extract from the data. But if we get to a point where we've pretty much convinced that the business rules we've extracted and the mechanisms for alerting us are valid, then we can pretty much turn this over to an automated process and actually do that operational streamlining that Eric was talking about. So I have a little play on words here, but I hope it works for you. I talk about the D2D challenge, and D2D is not just data to decisions, but in all contexts. We're looking at this, as it shows at the bottom of this slide, hopefully you can see, making discoveries and increasing revenue dollars from our analytics pipelines. And so, so in this context, I sort of have this little mantra to myself here now that I work with, and that is the first thing you want to do is characterize your data, extract features, extract the characteristics of your customers or whatever entity it is you're tracking in your space. Maybe if it's a patient in a health analytics environment, maybe it's a web user if you're looking at a sort of a cyber security issue. So characterize and extract characteristics, and then extract some context about that individual or about that entity. And then you gather those pieces that you've just created and put them into some kind of a collection from which you can then apply machine learning algorithms. And the reason I say it this way is that, let's just say you have a surveillance camera in an airport. The video itself is an enormous large volume, and it's also very unstructured, the video itself. But you can extract from video surveillance facial biometrics and identify individuals in the surveillance camera. So for example, at an airport, you can identify specific individuals. You can track them through the airport by cross-identifying the same individual in multiple surveillance cameras. And so it's the extracted biometric features that you're really mining and tracking. It's not the actual detailed video itself. And so, but once you have those extractions, then you can apply machine learning rules and analytics to make decisions of whether you need to take an action in a particular case of something happening incorrectly or something that you have an opportunity to make an offer. If you're, for example, you have a store in the airport and you see that customer coming your way and you know from other information about that customer, maybe they're really interested in buying stuff in the duty-free shop or something like that, make that offer. So what kind of things do I mean by characterization and contextualization? So by characterization, I mean, again, extracting the features and characteristics in the data. And this could be either machine-generated, that is, algorithms can actually extract, for example, biometric signatures from video, or sentiment analysis can extract customer sentiment through online reviews or social media. And some of these things may be human-generated, so that the human, being the business analyst, can extract additional features, which I'll show in the next slide. And some of these can be crowdsourced. And by crowdsourced, there's a lot of different ways you can think about that. But very simply, if, for example, your users come to your website and they put in search words, keywords, and they end up on a certain page and actually spend time there on that page, they actually understand that they're either viewing, browsing, clicking on things on that page. What that says to you is that keyword that they typed in at the very beginning is a good descriptor of that page because it landed the customer on the page that they were anticipating. And so you can add that additional piece of information, that is, customers who use this keyword actually identified this web page within our information architecture as the place where that content matches that keyword. And so the crowdsourcing is another aspect that sometimes people forget, that sort of tracking your customers' breadcrumbs, so to speak. How do they move through your space, whether it's an online property or a real property, and then use that sort of pathway that the customer takes as additional information about the things that they're looking at. So when I say human-generated things or machine-generated, I think about that in the context of sort of annotating or tagging specific data granules or entities, whether those entities are patients in a hospital setting or customers or whatever. And so there's different types of tagging and annotation. Some of that is about the data itself. That is, what are the things, what type of information is, what kind of information, what are the features, the shapes, maybe the texture, the patterns, anomaly, not anomaly behaviors. And then extract some semantics. That is, how does this relate to other things that I know? Is this, oh, this customer is, a electronics customer. This customer is a clothing customer, or this customer likes to buy music. So identifying some semantics about that. Customers who like music tend to like, entertainment. Maybe we can offer them some other entertainment property. So understanding the semantics, and also some provenance, which is basically say, well, where did this come from? What, who provided this assertion? What time? What date? Under what circumstance? So once you have all those annotations and characterizations, add to that then the next step, which is the context, sort of the who, what, when, where, why of it. Who was the user? What was the channel that came in on? What was the source information? What kind of reuses have we seen of this particular piece of information or data product? What does it sort of value in the business process? And then collect those things and manage them. Actually create a database, if you want to think of it that way. Make them searchable, reusable by other business analysts or by an automated process. That'll pick the next time I see these sets of features, the system can take this automatic action. And so we get to that sort of operational analytics efficiency. The more we collect useful, comprehensive information and then curate it for these use cases. So that's what we get to. We get at the end, then what? We get down to business. We do the data analytics. We look for interesting patterns, surprises, novelty, outliers, anomalies. We look for new classes and segments in the population. We look for associations and correlations and links among the various entities. And then we use all that to really drive our discovery, decision, and dollar-making process. So at the very end here, then we got the last slide I have is just basically summarizing, keeping the business analyst in the loop. Again, not extracting that human, but it's all important to keep that human in there. So these features that are provided by machines or human analysts or even crowdsourcing, we apply that combination of things to improve our training sets for our models. We end up with more accurate predictive models, fewer false positives and negatives, more efficient behavior, more efficient interventions with our customers or whoever. So at the end of the day, we're really just combining machine learning and big data with this power of human cognition, which is where that sort of tagging annotation piece comes in. And that can be through visualization or visual analytics types tools or immersive data environments or crowdsourcing. And at the end of the day, what this is really doing is accelerating our discovery, insights, and D2D. And those are my comments, so thank you for listening.
Hey, that sounds great. And let me go ahead and hand the keys over to Dr. Robin Bloor to give his perspective as well. Yeah, I'd like to hear you comment about that streamlining of operations concept. And you're talking about operational analytics. I think that is a big area that needs to be explored quite thoroughly. And it does, I guess real quick before Robin, I bring you back in, Kirk, it does require that you have some pretty significant collaboration among various players in the company, right? You have to talk to operations people. You got to get your technical people. Sometimes you have your marketing people or your web interface people. These are typically different groups. Do you have any best practices or suggestions on how to kind of get everyone put their skin in the game?
Well, I think it starts with the business culture of collaboration. In fact, I talk about the 3 C's of sort of the analytics culture. One is creativity, there's curiosity, and the third is collaboration. And so you want creative, curious people, but you also have to get these people to collaborate. And it really starts from the top, that sort of building that culture where people should share, openly share, and work together toward the common goals of the business.
Mm-hmm. It all makes sense, and you really do have to get good leadership at the top to make that happen. So let's go ahead and hand it off to Dr. Bloor. Robin, the floor is yours.
Okay, thank you for that intro, Eric. Okay, the way that these pan out, these shows, is that we tend, because we have two analysts, I get to see the analyst presentation that the other guy's doing, so I knew what Kirk was going to say, and I just go at a completely different angle so that we don't get too much overlap. So what I'm actually talking about, or intending to talk about here, is the role of the data analyst versus the role of the business analyst, and the way that I'm characterizing it in, well, tongue-in-cheek to a certain extent. This is a kind of Jekyll and Hyde thing. The difference being specifically that data scientists, in theory at least, know what they're doing, whereas business analysts are not so au fait with the way that the mathematics works, what can be trusted and what cannot be trusted. So let's just get down to the reason that we're doing this. The reason that data analysis has suddenly become a big deal, aside from the fact that we can actually analyze very large amounts of data and pull in data from outside the organization, is that it pays, And the way that I look at this, and I think this is only just becoming the case, but I definitely think it is the case, data analysis is really business R&D. What you're actually doing in one way or another with data analysis is you're looking at a business process of one sort or another, whether that's the interaction with the customer, whether that's with the way that, if you're a retail operation, the way that you deploy your stores. It doesn't really matter what the issue is. You're looking at a given business process and you're trying to improve it. The outcome of successful research and development is a change process. And you can think of manufacturing, if you want, as a useful example of this. But because, in manufacturing, people gather information about everything to try and improve the manufacturing process. But I think what's happened, or what is happening with big data, is all of this is now being applied to all businesses of any kind in any way that anyone can think of. So pretty much any business process is up for examination if you can gather data about it. So that's one thing, that's, if you like, that's going at the question of what can data analysis, what can analytics do for the business? Well, it can change the business completely. This particular diagram, which I'm not going to describe in any depth, but this is a diagram that we came up with as the culmination of the research project that we did for the first 6 months of this year. This is a way of representing a big data architecture, and a number of things that we're pointing out before I go on to the next slide. One is that, there are two data flows here. One is a real-time data stream which goes along the top of the diagram. The other is a slower data stream that goes along the bottom of the diagram. If you look at the bottom of the diagram, we've got Hadoop as a data reservoir. We've got various databases. We've got a whole data layer with a whole bunch of activity happening on it, most of which is analytical activity. The point that I'm making here, and the only point I really want to make here, is that the technology is hard. It's not simple. It's not easy. It's not something that anyone who's new to the game can actually just put together. This is fairly complex. And if you're going to instrument a business for doing dependable analytics across all its processes, then it's not something that's going to happen specifically quickly. It's going to require a lot of technology to be added to the mix. Okay, the question, what is a data scientist? I could claim to be a data scientist because I was trained actually in statistics before I was ever trained in computing. And I did an actuarial job for a period of time, so I know the way that a business organizes statistical analysis in order to run itself. And this is not a trivial thing, and there's an awful lot of best practice involved, both on the human side and on the technology side. So in asking the question, what is a data scientist, I put the Frankenstein picture simply because it's a combination of things that have to be knitted together. There is project management involved. There is deep understanding of statistics. There's domain business expertise, which is more the provenance of the business analyst than the data scientist necessarily. There's experience or the need to understand data architecture and to be able to build data architecture. And there's software engineering involved. In other words, it's probably a team. It's probably not an individual. And that means that it's probably a department that needs to be organized, and its organization needs to be thought about fairly extensively. Throwing into the mix the fact of machine learning, we couldn't do, I mean, machine learning is not new in the sense that most of the statistical techniques that are used in machine learning have been known about for decades. You know, there are a few new things. I mean, neural networks are relatively new. I think they're only about 20 years old. So, you know, some of it is relatively new. But the problem with machine learning was that we really didn't actually have the computer power to do it. And what's happened, apart from anything else, is that computer power is now in place. And that means that an awful lot of what we say data analysts or data scientists had done before in terms of modeling situations, sampling data, and then marshalling that in order to produce a deeper analysis of the data. Actually, we can just throw computer power at it in some cases. Just choose machine learning algorithms, throw it at the data, and see what comes out. And that's something that a business analyst can do. Right? But the business analyst needs to understand what they're doing. And I mean, I think that's the issue really more than anything else. This is, well, this is just you can know more about a business from its data than by any other means. Einstein didn't say that. I said that. I just put his picture up for credibility. But, you know, the situation is actually starting to develop is one where the technology, if properly used, and the mathematics, if properly used, will be able to run a business better than any individual. You know, we've watched this with, you know, IBM's, you know, first of all, it could beat the best guys at chess, and it could beat the best guys at Jeopardy. But eventually, we're going to be able to beat the best guys at running a company. The statistics will eventually triumph. And hard to see how that won't happen. It just hasn't happened yet. So what I'm saying, and this is kind of the complete message of my presentation, is, you know, there's two issues for the business. The first one is, can you get the technology right? Can you make the technology work for the team that is actually going to be able to preside over it and get benefits to the business? And then secondly is, can you get the people right? And both of these are issues. And they're issues that aren't, at this point in time, let's say they're not that easy to resolve. Okay, Eric, I'll pass it back to you, or I should perhaps pass it to Will.
Actually, yeah.
Thank you.
And Will Gorman. Yeah, there you go, Will. So let's see. Let me give you the keys to the WebEx. And just let us know what you got going on. Pentaho, obviously, you guys have been around for a while, and open source BI is kind of where you started, but you got a lot more than you used to have. So let us know what you got these days for analytics.
Absolutely. Hi, everybody. My name is Will Gorman. I'm the Chief Architect at Pentaho. Excuse me. For those who haven't heard of us, as just mentioned, Pentaho is a big data integration and analytics company. We've been in the business for 10 years. Our products have evolved, excuse me, I'm sorry. Our products have evolved side by side with the big data community, starting as an open source platform for data integration and analytics, innovating with technology like Hadoop and NoSQL, even before commercial entities formed around those tech. And now we have over 1,500 commercial customers and many more production deployments as a result of our innovation around open source. Our architecture is highly embeddable and extensible, purpose-built to be flexible as big data technologies in particular are evolving at a very rapid pace. Pentaho offers three main product areas that work together to address big data analytics use cases. The first product at the center of our architecture is Pentaho Data Integration, which is geared towards IT technologists and data engineers. This product offers a visual drag-and-drop experience for defining data pipelines and processes for orchestrating data within big data environments and traditional environments as well. This product is a lightweight, metadata-based data integration platform built on Java and can be deployed as a process within MapReduce or Yarn or Storm and many other batch and real-time platforms. Our second product area is around visual analytics. With this technology, organizations and OEMs can offer a rich drag-and-drop visualization and analytics experience for business analysts and business users via modern browsers and tablets, allowing the ad hoc creation of reports and dashboards, as well as a presentation of pixel-perfect dashboarding and reports. Our third product area focuses on predictive analytics, targeted for data scientists. Machine learning algorithms, as mentioned before, like neural networks and such, can be incorporated into a data transformation environment, allowing data scientists to go from modeling to production environments, giving access to predictions that may impact business processes very immediately, very quickly. All these products are tightly integrated into a single agile experience and give our enterprise customers the flexibility they need to address their business problems. We're seeing a quickly evolving landscape of big data and traditional technologies. While we hear from some companies in the big data space that the EDW is near an end, in fact, what we see in our enterprise customers is the need to introduce big data into existing business and IT processes, not replace those processes. This simple diagram shows a deployment architecture that we see often, it's a standard type of EDW deployment architecture, with data integration and BI use cases. Now this diagram is similar to Robin's slide on big data architecture. It incorporates real-time and historical data. As new data sources and real-time requirements emerge, we see big data as an additional part of the overall IT architecture. These new data sources include machine-generated data, unstructured data, the standard volume, velocity, and variety requirements that we hear about in big data that don't fit into traditional EDW processes. Pentaho works closely with Hadoop and NoSQL to simplify the ingestion, data processing, and visualization of this data, as well as blending this data with traditional sources to give customers a full view into their data environment. We do this in a governed manner so IT can offer a full analytics solution to their line of business. In closing, I'd like to highlight our philosophy around big data analytics and integration. We believe that these technologies are better together. Working with a single unified architecture enables a number of use cases that would otherwise not be possible. Our customers' data environments are more than just big data, Hadoop and NoSQL. Any data is fair game, and these data sources need to be available and work together to impact business value. Finally, we believe that in order to solve these business problems in enterprises very effectively through data, IT and lines of business need to work together on a governed, blended approach to big data analytics. Well, thank you very much for giving us the time to tell our story.
You bet. No, that's good stuff. And I want to get back to that slide of your architecture as we get to the Q&A. So let's move through the rest of the presentation. And thank you very much for that. You guys definitely have been moving quickly the last couple of years. I have to say that for sure. So Steve, let me go ahead and hand it over to you and just click there on the down arrow and go for it. So Steve, I'm giving you the keys, Steve Wilkes. Just click on that slide, use the down arrow on your keyboard.
There we go.
There you go.
That's a great photo you got of me there. So I'm Steve Wilkes. I'm the CTO at WebAction. We've only been around for the last couple of years, and we've definitely been moving fast as well since then. WebAction is a real-time big data analytics platform. And Eric mentioned earlier kind of how important real-time is and how real-time your applications are getting. So our platform is designed to build real-time apps and to enable the next generation of data-driven apps that can be built incrementally, added on, and allow people to build dashboards from those, the data that's generated from those apps, but focusing on real time. Our platform is actually a full end-to-end platform. doing everything from data acquisition, data processing, all the way through to data visualization, and enables multiple different types of people within an enterprise to work together to create true real-time apps, giving them insight into things happening in the enterprise as they happen. And this is a little bit different from what most people have been seeing in big data. So the traditional approach, well, traditional the last couple of years, approach with big data has been to capture it from a whole bunch of different sources, then pile it up into a big reservoir or lake or whatever you want to call it, and then process it when you need to run a query on it, to run large-scale historical analysis or even just ad hoc querying of large amounts of data. Now that works for certain use cases, but if you want to be proactive in your enterprise, if you want to actually be told what's going on rather than find out that something went on kind of towards the end of the day or the end of the week, then you really need to move to real time. And that switches things around a little. It moves the processing to the middle. So effectively, you're taking those streams of large amounts of data that is being generated continually within the enterprise, and you're processing it as you get it. And because you're processing it as you get it, you don't have to store everything. You can just store the important information or the things that you need to remember that actually happened. So if you're tracking the GPS location of vehicles moving down a road, you don't care where they are every second. You don't need to store where they are every second. You just need to care about, have they left this place? Have they arrived at this place? Have they driven off the freeway? So it's really important to consider that as more and more data is generated, and the three V's, velocity basically determines how much data is generated every day. The more data that's generated, the more you have to store. And the more you have to store, the longer it takes to process. But if you can process it as you get it, then you get a really big benefit, and you can react to that. You can be told that things are happening rather than having to search for them later. So our platform is designed to be highly scalable. It has three major pieces: the acquisition piece, the processing piece, and then the kind of delivery, visualization pieces of the platform. On the acquisition side, we're not just looking at machine-generated log data, like web logs or application server logs, all the other logs that are being generated. We can also go in and do change data capture from databases. So that basically enables us to, we've seen the ETL slides that Will presented. Traditional ETL, you have to run queries against the database. We can be told when things happen in the database through change data capture and receive those as events. Then there's obviously the social feeds and live device data that's being pumped to you over TCP or HTTP sockets. There's tons of different ways of getting data. And talking of volume and velocity, we're seeing volumes that are billions of events per day, right? So it's large amounts of data that's coming in that needs to be processed. That is processed by kind of a cluster of our servers. The servers all have the same architecture and are all capable of doing the same things, but you can configure them so that different servers do different things. And within the servers, we have a high-speed query processing layer that enables you to do kind of real-time analytics on the data, to do enrichment of the data, to do event correlation, to track things happening within time windows, to do predictive analytics based on patterns that are being seen in the data. Then that data can then be stored in a variety of places, your traditional RDBMS, enterprise data warehouse, Hadoop, big data infrastructure. And the same live data can also be used to power real-time data-driven apps. And those apps can have a real-time view of what's going on And people can also be alerted when important things happen. So rather than having to go in at the end of the day and find out that something bad really happened earlier on in the day, you can be alerted about it the second we spot it and go straight to the page, drill down, find out what's going on. So it changes the paradigm completely from having to analyze data after the fact to being told when interesting things are happening. And our platform can then be used to build data-driven applications. And this is really where we're focusing, is building out these applications for customers, with customers, a variety of different partners to show true value in real-time data analysis. So that allows people that companies that do cloud applications, for example, to be able to track customer usage over time and ensure that quality of service is being met, to spot real-time fraud or money laundering, to spot multiple logins or hack attempts, and those variety of kind of security events, to manage things like set-top boxes or other devices, ATM machines, to monitor them in real time for faults, failures that have happened, could happen, will happen in the future based on predictive analysis. And that goes back to the point of streamlining operations that Eric mentioned earlier, being able to spot when something's going to happen and organize your business to fix those things rather than having to call someone out to actually do something after the fact, which is a lot more expensive. Consumer analytics is another piece, be able to know when a customer is doing something while they're still in your store. Data center management, to be able to, in real time, monitor resource usage and change where things are running and be able to know about when things are going to fail in a much more timely fashion. So that's our product in a nutshell, and I'm sure we'll come back to some of these things in the Q&A session. Thank you.
Yes, indeed. Great job. Okay, good. And now next up in our lightning round, we've got Frank Sanders calling in from MarkLogic. I've known about these guys for a number of years. Very, very interesting database technology. So, Frank, I'm turning it over to you. Just click anywhere on that slide, use the down arrow on your keyboard, and you're off to the races. There you go.
All right. Thank you very much, Eric. So as Eric mentioned, I'm with a company called MarkLogic. And what MarkLogic does is we provide an enterprise NoSQL database. And perhaps the most important capability that we bring to the table with regards to that is the ability to actually bring all of these disparate sources of information together in order to analyze, search, and utilize that information in a system similar to what you're used to with traditional relational systems, right? And some of the key features that we bring to the table in that regard are all of the enterprise features that you'd expect from a traditional database management system, your security, your HA, your DR, your backup and restore, your ACID transactions, as well as a design that allows you to scale out either in the cloud or on commodity hardware so that you can handle the volume and the velocity of the information that you're going to have to handle in order to build and analyze this sort of information. And perhaps the most important capability is the fact that we're schema agnostic. And what that means practically is that you don't have to decide what your data is going to look like when you start building your applications or when you start pulling this information together, but over time you can incorporate new data sources, pull additional information in, and then use, leverage, and query and analyze that information just as you would anything that was there from the time that you started the design, okay? So how do we do that? How do we actually enable you to load different sorts of information, whether it be text, RDF triples, geospatial data, temporal data, structured data and values, or binaries? And the answer is that we've actually built our server from the ground up to incorporate search technology, which allows you to put information in, and that information self-describes, and then allows you to query, retrieve, and search that information regardless of its source or format. And what that means practically is that, and why this is important when you're doing analysis is that analytics and information is most important when it's properly contextualized and targeted, right? So a very important key part of any sort of analytics is search, and a key part of search is analytics, right? You can't really have one without the other and successfully achieve what you've set out to achieve, right? And I'm going to talk briefly about 3.5 different use cases of customers that we have in production that are using MarkLogic to power this sort of analytics, okay? So the first such customer is Fairfax County, and Fairfax County has actually built 2 separate applications. One is based around permitting and property management, and the other, which is probably a bit more interesting, is their Fairfax County Police Events application. And what the police events application actually does is it pulls information together like police reports, citizen reports and complaints, tweets, other information that they have, such as sex offenders and whatever other information that they have access to from other agencies and sources, right? And then they allow them to visualize that and present this to the citizens so that they can do searches and look at various crime activity, police activity, all through one unified geospatial index, right? So you can ask questions like, what is the crime rate within 5 miles, or what crimes have occurred within 5 miles of my location, okay? Another user that we've got, another customer that we have, is OECD. And why OECD is important to this conversation is because in addition to everything that we've enabled for Fairfax County in terms of pulling together information, right, all the information that you would get from all the various countries that are members of the OECD that they report on from an economic perspective, will actually allow you to target and drill into that, right? So you can see on the left-hand side, we're taking a view of Denmark specifically, and you can kind of see a flower petal above it that rates it on different axes, right? And that's all well and good, but what the OECD has done is they've gone a step further. So in addition to these beautiful visualizations and pulling all this information together, they're actually allowing you in real time to create your own Better Life Index, right, which you can see on the right-hand side. So what you have there is you have a set of sliders that actually allow you to do things like rank how important housing is to you, or income, jobs, community, education, environment, civic engagement, health, life satisfaction, safety, and your work-life balance. And dynamically, based on how you are actually inputting that information and weighting those things, MarkLogic's using its real-time indexing capability and query capability to actually then change how each and every one of these countries is ranked to give you an idea of how well your country or your lifestyle maps to a given country, okay? And the final example that I'm going to share is MarkMail. And what MarkMail really tries to demonstrate is that we can provide these capabilities and you can do this sort of analysis not only on structured information or information that's coming in that's numerical, but actually on more loosely structured, unstructured information, right? Things like emails. And what we've seen here is we're actually pulling information like geolocation, sender, company, facts and concepts like Hadoop being mentioned within the context of an email, and then visualizing it on a map, as well as looking at who those individuals and what lists across that sent, and a date. And this is where you're looking at things that are traditionally not structured, that may be loosely structured, but are still able to derive some structured analysis from that information without having to go to great lengths to actually try and structure it or process it ahead of time. And that's it.
Hey, okay, good. And we got one more. We've got Hannah Smalltree from Treasure Data, another very interesting company. And this is a lot of great content, folks. Thank you so much for all of you for bringing such good slides and such good detail. So, Hannah, I just gave the keys to you. Click anywhere and use the down arrow on your keyboard. You got it. Take it away.
Thank you so much, Eric. This is Hannah Smalltree from Treasure Data. I'm a director with Treasure Data, but I have a past as a tech journalist, which means that I appreciate 2 things. First of all, these can be long to sit through a lot of different descriptions of technology, and it can all sound like it runs together. So I really want to focus on our differentiators, and the real-world applications are really important. So I appreciate that all of my peers have been great about providing those. Treasure Data is a new kind of big data service. We're delivered entirely in the cloud in a software as a service or managed service model. So to Dr. Bloor's point earlier, this technology can be really hard, and it can be very time-consuming to get up and running. And with Treasure Data, you can get all of these kinds of capabilities that you might get in a Hadoop environment or a complicated on-premise environment in the cloud very quickly, which is really helpful for these new big data initiatives. Now, we talk about our service in a few different phases. So we offer some very unique collection capabilities for collecting streaming data, so particularly event data, other kinds of real-time data. And we'll talk a little bit more about those data types. That is a big differentiator for our service. As you get into big data, or if you're already in it, then you know that collecting this data is not trivial. When you think about a car with 100 sensors sending data every minute, even those 100 sensors sending data every 10 minutes, that adds up really quickly as you start to multiply the amount of products that you have out there with sensors. And it quickly becomes very difficult to manage. So we are talking with customers who have millions. We have customers who have billions of rows of data a day that they're sending us. And they're doing that as an alternative to trying to manage that themselves in a complicated Amazon infrastructure, or even trying to bring it into their own environment. We have our own cloud storage environment. We manage it, we monitor it, we have a team of people that's doing all of that tuning for you. And so the data flows in, it goes into our managed storage environment, and then we have embedded query engines so that your analysts can go in and run queries and do some initial data discovery and exploration against the data. We have a couple of different query engines, 4 actually now. You can use SQL syntax, which your analysts probably already know and love to do some basic data discovery, to do some more complex analytics with our user-defined functions, or even to do things as simple as aggregate that data and make it smaller so that you can bring it into your existing data warehouse environment. You can also connect your existing BI tools. Your Tableau is a big partner of ours, but really most BI visualization or analytics tools can connect via our industry standard JDBC and ODBC drivers. So it gives you this complete set of big data capabilities. You're allowed to export your query results or data sets anytime for free, so you can easily integrate that data, treat this as a data refinery. And I like to think of it more as a refinery than a lake, because you can actually do stuff with it. You can go through, find the valuable information, and then bring it into your enterprise processes. The next slide, we talk about the 3 V's of big data, or some people say 4 or 5. Our customers tend to struggle with the volume and velocity of the data coming at them. And so to get specific about the data types, clickstream, web access logs, mobile data is a big area for us, mobile application logs from custom web apps or other applications, event logs, and increasingly we have a lot of customers dealing with sensor data. So from wearable devices, from products, from automotive, and other types of machine data. So when I say big data, that's the type of big data that I'm talking about. Now, a few use cases to put this in perspective for you. We work with a retailer, a large retailer. They are very well known in Asia. They're expanding here in the U.S. You'll start to see stores. They're often called the Asian IKEA, so simple design. They have a loyalty app and a website. And in fact, using Treasure data, they were able to deploy that loyalty app very quickly. Our customers get up and running within days or weeks because of our software as a service architecture, and because we have all of the people doing all of that hard work behind the scenes to give you all of those capabilities as a service. So they use our service for mobile application analytics, looking at the behavior, what people are clicking on in those applications, in their mobile loyalty application. They look at their website clicks, and they combine that with our e-commerce and POS data to design more efficient promotions. They actually wanted to drive people into stores because they found that people, when they go into a store, spend more money. I know I'm like that. You pick up things, you spend more money. Another use case that we're seeing, digital video games, incredible agility. They want to see exactly what's happening in their game and make changes to that game even within hours of its release. So for them, that real-time view is incredibly important. We just released a game, but we noticed in the first hour that everyone's dropping off at level 2. How are we going to change that? They might change that within the same day. So real-time is very important. They're sending us billions of event logs per day, but this could be any kind of mobile application where you want some kind of real-time view into how somebody's using it. And finally, a big area for us is product behavior and sensor analytics. So with sensor data that's in cars, that's in other kinds of machines, utilities is another area for us, and wearable devices. We have research and development teams that want to quickly know what the impact of a change to a product is, or people interested in the behavior, how people are interacting with the product. And we have a lot more use cases, which of course we're always happy to share with you. And then finally, Just to show you how this can fit into your environment, we offer, again, the capability to collect that data. We have very unique collection technology. So again, if real-time collection is something that you're struggling with or you anticipate struggling with, please come look at the Treasure Data service. We have really unique capabilities for collecting, streaming data. You can also bulk load your data, store it, analyze it with our embedded query engines, and then, as I mentioned, you can export it right into your data warehouse. I think Will mentioned the need to introduce big data into your existing processes, so not go around or create a new silo, but how do you make that data smaller and then move it into your data warehouse. And you can connect your BI and visualization and advanced analytics tools. But perhaps the key points I want to leave you with are that we are a managed service, so it's software as a service. It's very cost effective, a monthly subscription service starting at a few $1,000s a month, and will get you up and running in a matter of days or weeks. So compare that with the cost, months and months of building your own infrastructure and hiring those people and finding it and spending all that time on infrastructure. If you're experimenting or if you need something yesterday, you can get up and running really quickly with Treasure Data. And just pointing you to our website and to our starter service. If you're a hands-on person who likes to play, please check out our starter service. You can get on, no credit card required, just name and email, and you can play with our sample data, load up your own data, and really get a sense of what we're talking about. So thanks so much. Also, check out our website. We were named a Gartner Cool Vendor in Big Data this year. Very proud of that. And you can also get a copy of that report for free on our website, as well as many other analyst white papers. So thanks so much.
Thank you very much. We got some time for questions here, folks. We'll go a little bit long, too, because we got a bunch of folks still on the line here. And I know I've got some questions myself, so let me go ahead and take back control. And then I'm going to ask a couple of questions, and Robin and Kirk, feel free to dive in as you see fit. So let me go ahead and jump right to one of these first slides that I checked out from Pentaho. So here, I love this evolving big data architecture. Can you kind of talk about how it is that this kind of fits together at a company? Because obviously you go into some fairly large organization, even a mid-sized company, and you're going to have some people who already have some of this stuff. How do you piece this all together? Like, what does the application look like that helps you stitch all this stuff together, and then what does the interface look like?
Great question, and the interfaces are a variety depending on the personas involved. But as an example, we like to tell the story. One of the panelists mentioned the data refinery use case. We see that a lot in customers. One of our customer examples that we talk about is Paytronics, where they have that traditional EDW data mart environment, and they're also introducing Hadoop, Cloudera in particular. And with the various user experiences in that, so first there's the data engineering experience. So how do you wire all these things up together? How do you create the glue between the Hadoop environment and the EDW? And then you have the business user experience, which we've talked about a number of BI tools out there, right? Pentaho has a more embeddable OEM-oriented BI tool, but there are great tools out there like Tableau and Excel, for instance, where folks want to explore the data. But usually we want to make sure that that data is governed, right? One of the questions in the discussion thread is, what about single version of the truth? How do you manage that? And without a technology like Pentaho Data Integration to blend that data together, not on the glass, but in the IT environment itself, it really protects and governs the data and allows for a single experience for the business analysts and business users.
Okay, good. That's a good answer to a difficult question, quite frankly. And let me get a question to each of the presenters, and then maybe Robin and Kirk, if you guys want to jump in too. So I'd like to go ahead and push this slide for WebAction, which I do think is a really very interesting company. Actually, I know Sami Akbay, who was one of the co-founders as well. And I remember talking to him a couple of years ago and saying, hey, man, what are you doing? What are you up to? I know you got to be working on something. And, of course, he was. He was working on WebAction under the covers here. And a question came in for you, Steve, so I'll throw it over to you, of data cleansing, right? Can we talk about this kind of a real-time component to this real-time capability? How do you deal with issues like data cleansing or data quality, or how does that even work?
So it really depends on where you're getting your feeds from. And typically, if you're getting your feeds from a database, as in change data capture, then and again, it depends there on how the data was entered. Data cleansing really becomes a problem when you're getting your data from multiple sources, or people are entering it manually, or you kind of have arbitrary text that you have to try and pull things out of. And that could certainly be part of a process, although that type of thing probably doesn't lend itself to true kind of high-speed real-time processing. Data cleansing typically is an expensive process. So it may well be that that could be done after the fact in the store side. But the other thing that the platform is really, really good at is correlation. So correlation and enrichment of data. So you can, in real time, correlate incoming data and check to see whether it matches a certain pattern or matches data that's been retrieved from a database or Hadoop or some other store. So you can correlate it with historical data is one thing you could do. The other thing that you can do is basically do analysis on that data and see whether it kind of matches certain required patterns. And that's something you can also do in real time. But the traditional kind of data cleansing where you're correcting company names or you're correcting addresses and all those types of things, those should either probably be done in the source or kind of after the fact, because they're expensive and you probably don't want to do those things in real time.
Yeah, and you guys are really trying to address of course, the real-time nature of things, but also get to people in time. We talked about there, I mentioned at the top of the hour, this whole window of opportunity, and you're really targeting specific applications at companies where you can pull together data, not going the usual route, going this alternate route, and do so in such a low latency that you can keep customers, for example, you can keep people satisfied. And it's interesting, when I talked to Sammy at length about what you guys are doing, he made a really good point. He said, if you look at a lot of the new web-based applications, let's look at things like Twitter or Bitly or some of these other apps, they're very different than the old applications that we looked at from, say, Microsoft, like Microsoft Word. And I often use Microsoft as sort of a whipping boy, and specifically Word, to talk about the evolution of software, because Microsoft Word started out, of course, as a word processing program. I'm one of those people who remember WordPerfect. I love being able to do the reveal keys, or the reveal code, basically, where you could see the actual code in there. You could clean something up. If your bulleted list was wrong, you can clean it up. Well, Word doesn't let you do that, and I can tell you that Word embeds a mountain of code inside every page that you do. If anyone doesn't believe me, go into Microsoft Word, type hello world, and then do export as or save as HTML, then open that document in a text editor, and it'll be about 4 pages long of text, of code just for 2 words. So you guys, I thought it was very interesting that Sammy talked about that, and that's what you guys are focused on, right, is identifying what you might call cross-platform or cross-enterprise or cross-domain opportunities to pull data together in such quick time that you can change the game, right?
Yeah, absolutely. And one of the keys that I think you did allude to it anyway is you really want to know about things happening before your customers do, or before they really, really become a problem. The example with set-top boxes, all these cable boxes, they emit telemetry all the time, loads and loads of telemetry. Not just kind of the health of the box, but kind of what you're watching and all that kind of stuff, right? And the typical pattern is you wait till the box fails, then you call your cable provider, and they'll say, well, we'll get out to you sometime between the hours of 6 a.m. and 11 p.m. in the entire month of November. And that isn't a really good customer experience. But if they could analyze that telemetry in real time, then they can start to do things like, well, we know this box is likely to fail in the next week based on historical patterns. Therefore, we'll schedule our cable repair guy to turn up at this person's house prior to it failing. And we'll do that in a way that suits us. Rather than having to send him from Santa Cruz up to Sunnyvale, we'll schedule everything in a nice order, traveling salesman pattern, etc., so that we can optimize our business. And so the customer's happier because they don't have a failing cable box, and the cable provider's happier because they have just streamlined things and they don't have to send people all over the place. So that's just a very quick example, but there are tons and tons of examples where knowing about things, you know, as they happen, before they happen, can save companies a fortune and really, really improve their customer relations.
Yeah, right. No doubt about it. And let's go ahead and move right on to MarkLogic. So as I mentioned before, I've known about these guys for quite some time, and really, so I'll bring you into this, Frank, you guys were far ahead of the whole big data movement in terms of building out your application. It's really a database, but building it out, and you talked about the importance of search. So a lot of people who follow the space know that a lot of the NoSQL tools out there are now bolting on search capabilities, whether through third parties or they're trying to do their own. But to have that search already embedded in there, baked in, so to speak, really is a big deal, because if you think about it, if you don't have SQL, well, then how do you go in and search the data, or how do you pull from that data resource? And the answer is that typically you search to get to the data that you're looking for, right? So I think that's one of the key differentiators for you guys, besides being able to pull data from all these different sources and store that data and really facilitate these sort of hybrid environments. I'm thinking that search capability is a big deal for you, right?
Yeah, absolutely. You know, in fact, it's the only way to solve the problem consistently when you don't know what all the data is going to look like, right? If you cannot possibly imagine all the possibilities, then the only way to make sure that you can locate all of the information that you want, that you can locate it consistently, and you can locate it regardless of how you evolve your data model and your data sets, is to make sure that you give people generic tools that allow them to interrogate that data. And the easiest, most intuitive way to do that is through a search paradigm, right? You know, and through the same approach that search takes, where you create an inverted index. You have entries where you can actually look into those and then find records and documents and rows that actually contain the information you're looking for, to then return it to the customer and allow them to process that as they see fit.
Yeah, and you know, we talk about this a lot, but you're giving me a really good opportunity to kind of dig into it. The whole search and discovery side of this equation, first of all, it's a lot of fun. For anyone who likes that stuff, this is the fun part, right? But the other side of the equation, the other side of the coin, I should say, is that it really is an iterative process, and you've got to be able to, well, here I go using some of the marketing language, have the conversation with the data, right? In other words, you need to be able to test a hypothesis, play around with it, see how that works, maybe that's not there, test something else, and constantly change things and iterate and search and research and think about stuff. And that's a process. And if you have big hurdles, meaning long latencies or a difficult user interface, or you got to go ask IT, that just kills the whole analytical experience, right? So it's important to have this kind of flexibility and to be able to use searches. And I like the way you depicted it here, because you're looking at searching around different sort of concepts or keys, if you will, key values, and there are different dimensions. You want to be able to mix and match that stuff in order to enable your analysts to find useful stuff, right?
Yeah, absolutely. And I mean, hierarchy is an important thing as well, right? So that when you include something like a title, right, or a specific term or value, that you can actually point to the correct one. So that if you're looking for a title of an article, you're not getting titles of books, right, or you're not getting titles of blog posts, right? The ability to distinguish between those and through the hierarchy of the information is important as well. And, you know, to your point about iterative development, absolutely, right? You know, the ability for our customers to actually pull in new data sources in a matter of hours, start to work with them, evaluate whether or not they're useful, and then either continue to integrate them or leave them by the wayside is extremely valuable when you compare it to a more traditional application development approach, where what you end up doing is you have to figure out what data you want to ingest, source the data, figure out how you're going to fit it into your existing data model, or model that data, change that data model to incorporate it, and then actually begin the development, right? Where we kind of turn that on its head and say, just bring it to us, allow you to start doing development with it, and then decide later whether or not you want to keep it, or almost immediately whether or not it's of value.
Yeah, that's a really good point. That's a good point. So let me go ahead and bring in our fourth presenter here. Treasure Data. I love these guys. I didn't know much about them, so I was kind of kicking myself, and then Hannah came to us and told us what they were doing. And as Hannah mentioned, she was a media person, and she went over to the dark side.
I did. I defected.
That's okay, though, because you know what we like in the media world, so it's always nice when a media person goes over to the vendor side, because you understand that, hey, this stuff is not that easy to articulate, and it can be difficult to ascertain from a website exactly what this product does versus what that product does. And what you guys are talking about is really quite interesting. Now, you are a cloud-managed service, so any data that someone wants to use, they upload to your cloud. Is that right? And then you will ETL or CDC additional data up to the cloud? Is that how it works?
Well, yeah. So let me make an important distinction. Most of the data, the big data that our customers are sending us, is already outside the firewall. So mobile data, sensor data that's in products. And so we're often used as an interim staging area. So data is not often coming from somebody's enterprise into our service so much as it's flowing from a website, a mobile application, a product with lots of sensors in it into our cloud environment. Now, if you'd like to enrich that big data in our environment, you can definitely bulk upload some application data or some customer data to enrich that and do more of the analytics directly in the cloud. But a lot of our value is around collecting that data that's already outside the firewall, bringing it together into one place. So even if you do intend to bring a subset of that behind your firewall and do more of your advanced analytics or bring it into your existing BI or analytics environment, it's a really good staging point because you don't want to bring a billion rows a day into your data warehouse. It's not cost effective. It's even difficult if you're planning to use Hadoop to store that somewhere and then bulk, batch upload. So we're often the first point where data is getting collected that's already outside the firewall.
Yeah, that's a really good point, too, because a lot of companies are going to be nervous about taking their proprietary customer data, putting it up in the cloud, and you have to manage that whole process. And what you're talking about is really giving people a resource for crunching those heavy-duty numbers of, as you suggest, data that's third-party, like mobile data and social data and all that kind of fun stuff. That's pretty interesting.
Yeah, absolutely. And companies that are nervous about the cloud, I said this data was already outside. And so, yeah, before bringing it in, can you do, and I really like the refinery term, as I mentioned, versus the lake. So can you do some basic refinery, get the good stuff out, and then bring it behind the firewall, into your other systems and processes for deeper analysis. So it's really a tool where data scientists can do real-time data exploration of this new big data that's flowing in.
Yeah, that's right. Well, let me go ahead and bring in our analysts, and we'll kind of go back in reverse order. I'll start with you, Robin, with respect to treasure data, and then we'll go to Kirk for some of the others, and then back to Robin and then back to Kirk, just to kind of get some more assessment of this. And, the data refinery, Robin, that Hannah is talking about here, I love that concept. I've heard only a few people talk about it that way, but I do think that you've certainly mentioned that before, and it really does speak to what is actually happening to your data, because of course a refinery, it basically distills stuff down to its root level. If you think about oil refineries, I actually studied this for a while, and it's pretty basic, but the engineering that goes into it needs to be exactly correct, or you don't get the stuff that you want. So I think it's a great analogy. What do you think about this this whole concept of the Treasure Data Cloud service helping you tackle some of those very specific analytical needs without having to bring stuff in-house?
Well, I mean, it obviously depends on your circumstance as to how convenient that is, but anybody that's actually got a ready-made process is already going to put you ahead of the game if you haven't got one yourself. I mean, so that's, it's the first takeaway for something like that. Somebody's assembled something, they've done it, it's proven in the marketplace, and therefore there's some kind of value in the fact that a lot of work has already gone into it. And there's also the very general fact that refining of data is going to be a much bigger issue than it ever was before. I mean, it's not talked about, in my opinion anyway, it's not talked about as much as it should be. Simply, The number, I mean, apart from the fact that the size of the data has grown, the number of different sources and the variety of those sources has grown quite considerably, and the reliability of the data in terms of whether it's clean, the need to disambiguate the data, all sorts of issues that rise up just in terms of the governance of the data before you actually get around to being able to do reliable analysis on it. You know, if your data's dirty, then your results will be skewed in some way or other. So, you know, that is something that has to be addressed, it has to be known about. And, you know, the treasure data are providing, as far as I can see, a very viable service to assist in that.
Yes, indeed. Well, let me go ahead and bring Kirk back into the equation here just real quickly. But I wanted to take a look at one of these other slides and just kind of get your impression of things, Kirk. So maybe let's go back to this MarkLogic slide. And by the way, Kirk provided a link, if you didn't see it, folks, to some of his class discovery slides, because that's a very interesting concept. And I think this was kind of brewing in the back of my mind, Kirk, as I was talking about this a moment ago. This whole question that one of the attendees posed about how do you go about finding new classes? Because, and this is, I love this topic because it really does speak to the sort of the difficult side of categorizing things, because I've always had a hard time categorizing stuff. I'm like, oh God, I could fit in 5 categories. Where do I put it? So I just don't want to categorize anything, right? And that's why I love search, because you don't have to categorize, you don't have to put it in a folder. Just search for it and you'll find it if you know how to search. But if you're in that process of trying to segment, because that's basically what categorization is, it's segmenting, finding new classes, that's kind of an interesting thing. Can you kind of speak to the power of search and semantics and hierarchies, for example, as Frank was talking about with respect to MarkLogic and the role that plays in finding new classes? What do you think about that?
Well, first of all, I want to say you were reading my mind because I wanted to make, I was thinking of a question even before you were talking, this whole semantic piece here that MarkLogic presented. And if you went back to my slide, you would see, you don't have to do this, but I'm back on the slide 5 of what I presented this afternoon. I talked about the semantics of the data needs to be captured. So this whole idea of search, there you go. So this whole idea of search, I firmly believe in that. I've always believed in that. With big data, I mean, it sort of takes the sort of the analogy of the internet. I mean, just the web. I mean, having the world knowledge and information and data on a web browser is one thing, but to have it searchable and retrievable efficiently, as a lot of the big search engine companies provide for us, that's where the real power of discovery is connecting the search terms, the sort of the user interest areas to the particular data granule, the particular web page, if you want to think of the web example, or the particular document, if you're talking about a document library, or a particular customer type of segment, if that's your space. And semantics gives you that sort of knowledge layering on top of just a word search. Because if I'm searching for a particular type of thing, understanding that it's a member of a class of such things that have a certain relationship to other things, you can include that sort of relationship information, that class hierarchy information, to find things that are similar to what you're looking for, or sometimes even the exact opposite of what you're looking for, because that in a way gives you sort of additional power of understanding. Well, show me something that's opposite to this. So it helps me understand this if I can see something that's opposite of this. And so that semantic layer is just an invaluable component that's frequently missing. And it's interesting that this would come up here in this context, because I've taught a graduate course in database, data mining, learning from data, data science, whatever you want to call it, for over a decade. And one of my units in this semester-long course is on semantics and ontologies. And frequently my students sort of look at me like, what does this have to do with what we're talking about? And then, of course, by the end, I think they do understand that it's putting that data in some kind of a knowledge framework, so that, just for example, if I'm looking for information about a particular customer behavior, understanding that behavior occurs, let's say, what do people buy at a sporting event? You know, what kind of product can I offer to my customers when I notice on their social media, you know, Twitter or Facebook, that they said they're going to a sporting event, you know, football, baseball, hockey, whatever, World Cup, whatever it might be. Understanding, okay, so sporting event, so they say they're going to a, you know, let's say a baseball game. Okay, I understand that baseball is a sporting event. I understand it's usually a social thing. You go with people, and I understand that it's usually in an outdoor space. I mean, understanding all those contextual features enables sort of more powerful sort of segmentation of the customer, as well as, you know, sort of personalization of the experience that you're giving them when they, for example, if they're interacting with your, you know, your space through a mobile app while they're sitting in the stadium. So all that kind of stuff just brings so much more power and discovery potential to the data, and that sort of indexing idea of indexing data granules by their you know, semantic place in the knowledge space is really pretty significant, and I really was impressed that came up today, because I think it's sort of a fundamental thing that's often missed.
Yeah, it sure is. And it's very important in the discovery process. It's very important in the classification process. And, you know, if you think about it, Java works in classes. It's an object-oriented, I guess, more or less, you could say, form of programming. And Java works in classes. So as you're actually designing software, this whole concept of trying to find new classes is actually pretty important stuff in terms of the functionality you're trying to deliver. Because especially in this new wild, woolly world of big data where you have so much Java out there running so many of these different applications, you know, there are 87,000 ways or more to get anything done with a computer, to get any kind of bit of functionality done. You know, one of my running jokes when people say, oh, you could build a data warehouse using NoSQL. I'm like, well, you could. Yeah, that's true. You could also build a data warehouse using Microsoft Word. It's not the best idea. It's not going to perform very well, but you can actually do it. So the key is you have to find the best way to do something. Well, let me go ahead and put this. Oh, go ahead.
Let me just respond to that. I mean, it's interesting you mentioned the Java class example, which didn't come to my mind until you said it, but one of the aspects of Java and classes, and, you know, that sort of object orientation, is that there are methods that are, you know, that bind to specific classes. And this is really sort of the message that I was trying to send to my presentation. And that is, once you understand sort of these data granules, you know, these knowledge nuggets, these tags, these annotations, these semantic labels, then you can bind a method to that. That is basically, you know, send out this, you know, have this reaction or this response, have your system provide this sort of automated, proactive response to this thing the next time we see it in the data stream. And so that concept of binding, you know, actions and methods to specific classes of things is really one of the powers of automated real-time analytics, and I think you sort of hit on something there.
Good, good, good. Well, this is good stuff. So let's see, Will, I'm going to pan it back to you and actually throw a question to you from the audience. We've got a few of those in here too. And folks, so we're going long because we want to get to some of these great concepts and these good questions. So let me throw a question over to you from one of the audience members who's saying, I'm not really seeing how business intelligence is distinguishing cause and effect. In other words, as these systems are making decisions based upon observable information, how do they develop new models to learn more about the world? And it's an interesting point. So I'm hearing a cause and effect correlation here, root cause analysis. You know, that's some of the sort of higher end stuff in the analytics that you guys talk about, as opposed to traditional BI, which is really just kind of reporting and kind of understanding what happened. And of course, your whole direction, just looking at your slide here, is moving toward that predictive capability, toward making those decisions, or at least making those recommendations, right? So the idea is that you guys are trying to service the whole range of what's going on, and you're understanding that the key, the real magic, is in that analytical component there on the right.
Absolutely, and I think that question is somewhat peering into the future, in the sense that data science, and it was mentioned before, we saw the slide with the requirements of a data scientist. It's a pretty challenging role for someone to be in. You have to have that rich knowledge of statistics and you know, science. You need to have the domain knowledge to apply your mathematical knowledge to the domain. So what we're seeing today is there aren't these out-of-the-box predictive tools that a business user could pull up in Excel and then automatically predict their future, right? It does require that advanced knowledge and technology at this stage. Now, someday in the future, it may be that some of these systems, these scale-out systems become sentient and start doing some wild stuff. But I would say at this stage, you still have to have a data scientist in the middle to continue to build models. These models, these predictive models around data mining and such, are highly tuned and built by the data scientists. They're not generated on their own, if you know what I mean.
Yeah, exactly. That's exactly right. And one of my lines is, machines don't lie, at least not yet.
Not yet, exactly.
I did read an article. I have to write something about this, about some experiment that was done at a university where they said that these computer programs learn to lie, but I got to tell you, I don't really believe it. We'll do some research on that, folks. And for the last comments here, Rob and I are going to bring you back in to take a look at this WebAction Platform, because this is very interesting, and this is what I love about our whole space, is that you get such different perspectives and different angles taken by the various vendors to serve very specific needs. And I love this format for our show because we got 4 really interesting vendors that are frankly not really stepping on each other's toes at all. These are all doing different bits and pieces of the same overall need, which is to use analytics to get stuff done. But I just wanted to get your perspective on this specific platform and their architecture, how they're going about doing things. I find it pretty compelling. What do you think?
Well, I mean, it's pointed at, extremely fast results from streaming data. And as such, you have to architect for that. I mean, you're not going to get away with doing anything amateurish as regards any of that stuff. I think this is extremely interesting. And I think that, one of the things that we've witnessed over the past, I think you and I have been, starting to, our jaw has been dropping more and more over the past couple of years as we saw more and more stuff emerge that was just like extraordinarily fast, extraordinarily smart, and pretty much unprecedented. This is obviously, WebAction isn't, this isn't its first rodeo, so to speak. It's been out there and taking names to a certain extent, so I don't suppose we should be surprised that the architecture is fairly swish, but it surely is.
Well, I'll tell you what, folks, we burned through a solid 82 minutes here. A big thank you to all those folks who have been listening the whole time. If you have any questions that were not answered, don't be shy. Send an email to yours truly. You should have an email from me lying around somewhere. And a big, big thank you to both of our presenters today, to Dr. Kirk Borne and to Dr. Robin Bloor. And Kirk, I'd like to further explore some of that semantic stuff with you, perhaps on a future webcast, because I do think that we're at the beginning of a very new and interesting stage now where we're going to be able to leverage a lot of the ideas that people have and make them happen much more easily, because guess what? The software is getting more, it's getting less expensive, I should say. It's getting more usable, and we're just getting all this data from all these different sources. And I think it's going to be a very interesting and fascinating journey over the next few years as we really dig into what this stuff can do and how it can improve our businesses. So a big thank you to Techipedia as well, and of course to our sponsors, Pentaho, WebAction, MarkLogic, and Treasure Data. And folks, wow, with that we're going to conclude. But thank you so much for your time and attention. We'll catch you in about a month and a half with the next show. And of course, the briefing room keeps on going. DM Radio keeps on going. All of our other webcast series keep on rocking and rolling, folks. Thank you so much. We'll catch you next time. Bye-bye.